Hello students, welcome back to my channel. Once again, hope all are preparing for your exam students. So, previously I have explained transport numbers. Have you all watched students? Have you noted down in your notebooks? Okay. Today we are going to learn another important topic from electrochemistry, and the topic is Kohlrausch law of independent migration of ions. Okay, are you all ready with the notebook and pen, students? Kindly put the side heading Kohlrausch law of independent migration of ions. Kohlrausch. Okay, always after putting the side heading, kindly underline the side heading, students. Okay. Now, what do we learn under this Kohlrausch law of independent migration of ions? Generally, in a solution at ordinary dilution, what is meant by ordinary dilution? Adding little amount of water to an electrolyte. Okay. Now, in such solutions, that is at ordinary dilution, what do we observe, students? We observe that each ion is attached to its counter ion. Prior to this, you all know that when we add some water to an electrolyte, that means in a solution, when we add water, it dissociates into positive and negative ions, right? That you all know. Now, what will be the situation of these ions? Each ion will be attached to its counter ion. Each ion means positive to negative or negative to positive. What does it mean? That means there will be some attractions or some attractive forces between the opposite ions. Because of these attractions only, na students, each ion will be attached to the opposite ion. Okay. Hence, their mobility will be difficult. What does it mean? Mobility will be difficult means when they are attracted or when they are attached to one another, they cannot move easily. That's what I have written here. Their mobility will be difficult in a solution at ordinary dilution. What is the reason? Positive ion will be attached to the negative ion by some attractive forces. Okay. Now, suppose you add some amount of water. That means when such a solution is further diluted. So, suppose previously you added 5 ml of water. Now you are adding 10 ml of water. That means you are further diluting the solution. Now what happens, students? The distance between the opposite ions automatically increases. Okay. Now add more amount of water. Still 20 ml of water you add, or maximum water if we add, that is we call it as maximum dilution or infinite dilution. What happens? That means the concentration becomes 0. Okay, that is at 0 concentration. Dissociation of the electrolyte is come this point already we have learned, students. 100% it will be complete at 0 concentration or at infinite or maximum dilution. This point you must be knowing, because previous topics we have learned this. Dissociation of the electrolyte is complete, and now the opposite ions are far away from one another as the interactions between them disappears. So when it is diluted completely, that means at 0 concentration, what happens, students? What all attractive forces are existing between the opposite ions, all those interactions will be disappeared. Because of this, what happens? The opposite ions will be moving far apart from one. One will be east towards east and one will be towards west. So like that we can explain. At infinite dilution, that means at 0 concentration, dissociation of the electrolyte is complete and the opposite ions are now far away from one another as the interactions or the attractions between them completely disappear. Okay. Now once the interactions or the attractions disappear, what will be the situation of the opposite ions? What happens, students? Now they are free to move. Previously in the beginning, at ordinary dilution or at normal dilution, we have seen there will be attractions and their mobility will be difficult. Now at infinite dilution, what happened? All the attractions are broken and now they are free to move. So each ion moves independently towards opposite electrodes. So you might get a doubt, ma'am, where are the electrodes? Okay, this is under the influence of electric field. Now each ion moves independently towards opposite electrodes. How they are moving? With maximum speed, with maximum mobility, and they can contribute maximum equivalent conductance. Okay, students. Now this is all at which point? At infinite dilution. There are no attractions between the opposite ions. So positive ion moving towards negative electrode, negative ion moving towards positive electrode. They are moving with the maximum speed, and we can say that now they are able to contribute maximum equivalent conductance, and this we know that which depends on its own nature and not on the opposite ion with which it is associated. Okay, so how can we say that they are contributing maximum equivalent conductance? Because they are moving with maximum mobility and also depending only on its own nature, but not on the opposite ion with which it is associated. How can we say that it is not depending on the counter? Because there are no interactions between the counter ions. Okay, students, till here you understood? Now, next sentence you see. Now, what we are learning? Kohlrausch law of independent migration of ions. So, here Kohlrausch in the year 1875, he proposed a law which is called as Kohlrausch law, based on his studies of equivalent conductance. Okay, so taking into consideration the equivalent conductances of different electrolytes at infinite dilution, Kohlrausch in the year 1875, he proposed a law called as Kohlrausch law of independent migration of ions. How did he propose, students? Based on the studies of equivalent conductance of different electrolytes. So he has taken different electrolytes and observed their equivalent conductance, how much they are contributing to equivalent conductance at infinite dilution. Based on all this data, he could propose Kohlrausch law. Now, how does the statement of Kohlrausch law go? This according to Kohlrausch law, the equivalent conductance of an electrolyte at infinite dilution. Students, he proposed this law based on the equivalent conductance of different electrolytes at infinite dilution. Okay. Now, the statement of Kohlrausch law is, this law states that, or according to Kohlrausch law, the equivalent conductance of an electrolyte at infinite dilution is equal to, carefully listen, it is equal to sum of equivalent conductivities of both anion and cation. So you all know, on dilution electrolyte dissociates into positive and negative ions. So here the equivalent conductance of an electrolyte at infinite dilution will be equal to sum of equivalent conductivities of both anion and cation. So how do we represent this, students? Below I have written, see, lambda infinity, okay, is equal to lambda naught of C plus lambda naught of A. Okay, lambda naught of C means equivalent conductance of cation at infinite dilution, and lambda naught A means equivalent conductance of anion at infinite dilution. Okay, so this lambda naught infinity is equivalent conductance of the electrolyte, students. So at infinite dilution. Okay, so equivalent conductance of an electrolyte at infinite dilution. We represent like this: lambda infinity naught, this is at infinite dilution, is equal to lambda naught C. That means equivalent conductance of cation at infinite dilution, and lambda naught A is equivalent conductance of anion at infinite dilution. For example, if we take KCl, potassium chloride, equivalent conductance of KCl at infinite dilution will be equal to lambda naught of K plus lambda naught of Cl minus. Lambda naught of K plus is potassium equivalent conductance at infinite dilution, and Cl minus equivalent conductance at infinite dilution. Okay, students. So how do we conclude, students? At infinite dilution, the conductance or the equivalent conductance exhibited by Cl minus will be constant, whether the opposite ion or whether the counter ion is K plus or Na plus. Okay, so if K plus is attached one value of equivalent conductance, Na plus is attached one value of conductance. No, it's not like that. Okay, it will be constant whether the opposite ion is K plus or Na plus, because it is depending only on its nature and not on the counter ion. Similarly, the conductance exhibited by K plus at infinite dilution will be constant whether the opposite ion is Cl minus or Br minus or whatever. Okay, students. So here it doesn't depend upon the counter ions with which it is associated. It will be depending only on its nature. So that's what we mentioned here. The conductance exhibited by K plus at infinite dilution. Here also you add, students. The conductance exhibited by Cl minus at infinite dilution will be constant whatever might be the counter ion. Okay, students, this is all about Kohlrausch law of independent migration of ions. Okay, hope you all understood. This is sufficient for your exam, students. Note down all these points, learn carefully. It's very easy to learn also. So whoever is watching for the first time, kindly subscribe to the channel so that you will not miss the notification, students. And also don't forget to like the video and kindly share with your friends. Okay, meet you all in the next video with a new topic, students. Take care. Bye-bye.